Problem 72. Consider the endothermic reaction. 2 NH3s form 3 H2s and N2. What effect does each of the following changes have on the direction of equilibrium? So you're given a list of 6 changes, and you're supposed to indicate does the change cause the reaction to proceed towards the product, to proceed to the right, to form more products, or does it cause it to shift to the left to form more reactants? Now let's copy this chemical equation down over here on the right. So you can see I've listed the reactants and products over here on the right. Now I've also added energy as one of the reactants, okay? And that's because we're told that this is an endothermic reaction. And endothermic reactions, energy is absorbed. So as it goes forward, energy is absorbed. It's one of the reactants. In an endothermic reaction, energy is on the left. Now let's think about the reaction being at equilibrium, okay? The amount of reactant material and product material is balanced when it's at equilibrium. So you have the amount of reactants and products balancing each other, and I like to think of them as being on both ends of a balance beam or a seesaw. And let's have this picture in mind as we investigate the 6 disturbances or the 6 changes. The first change is to increase the amount of NH3. Now where is NH3? Well, it's one of the reactants. If you increase the amount of NH3 in the reaction mixture that was at equilibrium, what you're doing is you're adding more reactant, and you're causing the balance beam to fall down over on the left-hand side. You got too much reactant now. To get back to equilibrium, you need to, get rid of the reactant and form more product. Let me find a good color here. How about green? So there's too much reactant. You need to lose some of it and form more product. So in this case, the reaction must shift to the right to get back to equilibrium. Okay, you take some of the reactant material and you use it to form more product. That'll put it back in balance. Now, the next disturbance is to decrease the amount of N2. So N2 is one of the products, and when you remove some of the N2, well, now the product side is kind of lighter than it was in the balanced case. So you have less product. That's going to lighten up the load over here. And so the balance beam, again, would be tilted this way. To get back to equilibrium, you need to take some of this reactant material and form more product. And that would put it back in balance. And so decreasing N2 causes the reaction to shift to the right again to get back to equilibrium. The third disturbance, increasing the H2. Okay, H2 is one of the products, and if you add some H2, what you're doing is now you're putting more product in the reaction mixture, and now you got too much product. Okay, so the balance beam is tipping over to the right, and now you got too much product. And to get back to balance, to get back to equilibrium, you have to take some of that product material and reform some reactant. So in this case, the reaction has to shift back to the left, to get back to equilibrium. Okay. So increasing the H2 causes it to shift left. What about increasing the temperature? Increasing the temperature. You're adding heat in this case. Now, where is heat? Well, this is an endothermic reaction, remember? Heat is one of the requirements. It's on the reactant side. So if you increase the temperature, it's kind of like you're adding reactant material. Okay, Increasing the temperature, you're adding reactant material. Now you got more reactant. The balance beam is too heavy over here now, so it shifts in this direction. And to get back to equilibrium, you're going to have to take some of that reactant material and form some product, okay, to put it back in balance. So increasing the temperature, the reaction shifts to the right to get back to equilibrium. Decreasing the temperature would have the opposite effect. Okay, remember, decreasing the temperature, you're removing heat, you're removing energy. Energy is one of the reactants for an endothermic profile or endothermic reaction. If you're decreasing the temperature, you're removing that energy, and now the reactants are kind of lightened up, and the balance beam is tilted to the left because you removed some of that necessary heat. And so to get back to equilibrium, it has to shift to the left. Take some of that product and reform some reactant. So the reaction shifts to the left to get back to equilibrium. You can't quite, oh, there you go, you can see it now. It shifts to the left to get back to equilibrium. Finally, the last one, increasing the pressure. Okay, increasing the pressure. Now, pressure is kind of tricky. It doesn't really affect this reaction, okay? It's not one of the chemicals, okay? If you're just increasing the pressure in general, it has no effect unless the added gas pressure has one or more of the reaction gases, of course, okay? So if increasing the pressure, you're injecting more gas. If you're injecting one of these, three gases, the hydrogen and the nitrogen are also gases, then that could, of course, affect it. Now, there's a different way to increase the pressure, and that's by, if you have the reaction happening inside of a chamber, okay, maybe like a gas chamber with a piston, maybe the reaction is happening inside here. And one way to increase the pressure is you lower that piston. And so suppose you squeeze the reaction mixture down into a smaller volume, that would increase the pressure. It would squeeze all those gas particles into a smaller volume. That could, in fact, in this way, if you increase the pressure in this way, it would actually cause the reaction to shift to the left, okay? Because you got 2 moles of gas over here versus 1, 2, 3, 4 moles of gas over there. It would shift to the side. It would make it shift to the left because 2 moles of gas occupy less volume than 4 moles of gas. So this is no effect unless increasing the pressure is done this way by reducing the volume. Except, so I'll say except if done by reducing the volume. Okay, in that case, it would cause it to shift to the left. So it's kind of a complicated situation. We normally don't talk about this in our course. If you take general chemistry, you'll talk more about pressure effects on equilibrium. So I hope you understood that. If not, don't worry so much about it.